Hello everyone, welcome to my channel. Let's step into the world of MongoDB together. This video will cover what MongoDB is, how to set it up, and explore basic user scenarios of this leading name in NoSQL databases. Let's explain what is NoSQL. NoSQL is not only SQL. NoSQL refers to a broad category of database management systems that diverge from the traditional relational database model. Unlike SQL databases, NoSQL databases are designed to handle large volumes of unstructured or semi-structured data, offering greater flexibility and scalability. NoSQL databases are often preferred for their ability to efficiently manage distributed and heterogeneous data sources, making them well suited for modern web applications, big data processing, and real-time analytics. Let's explain table structure in SQL. In the example provided in SQL, a table is structured using a combination of columns and rows. Each column represents a specific attribute or piece of information, while each row represents a record or entry in the table. The table name serves as its identifier within the database. Columns define the attributes or fields of the data stored in the table, with each column having a name and a data type specifying the type of data it can store. Let's explain collection structure in MongoDB. In MongoDB, a collection is a group of documents stored in database similar to how tables are organized in SQL. Each collection has a name that identifies it within the database. Documents within collections represent individual records or entries analogous to rows in SQL tables. Documents are structured as a JSON-like object, offering flexibility in data schema. Fields within documents define attributes or pieces of information similar to columns in SQL tables. MongoDB's flexible schema allows for varying structure within collection, adapting easily to changing data requirements. Each document has a unique identifier called the ID field, serving as its primary key within the collection. Let's explain document structure in MongoDB. In MongoDB, a document is a fundamental unit of data storage, resembling a record or entry in traditional databases. Documents are organized within collections, with each document representing a distinct piece of information. MongoDB documents are structured as key-value pairs, providing flexibility in data representation. Each document consists of one or more key-value pairs, where keys represent the field name or attributes, and value represent the corresponding data associated with each key. These key-value pairs collectively define the structure and content of the document. Unlike SQL tables, MongoDB documents do not enforce a fixed schema, allowing for varying structure within the same collection. Documents are typically represented in a JSON-like format, making them easy to read, write, and manipulate. This format allows for nesting of objects and arrays within documents, enabling the storage of complex data structure. Let's explain why MongoDB. Header is flexible data model. MongoDB's document-oriented data model allows for flexible schema design, accommodating changes in data structure without downtime or complex migrations. Scalability and performance. MongoDB is designed to scale horizontally across clusters of commodity hardware, making it well suited for handling large volumes of data and high traffic loads. Its distributed architecture ensures efficient data distribution and workload balancing, resulting in improved performance. High availability and fault tolerance. MongoDB provides built-in replication and automatic failover capabilities, ensuring data availability and reliability in the event of hardware failures or network partitions. This ensures continuous operation and minimal downtime for applications. Rich query language and indexing. MongoDB supports a powerful query language with rich functionality, including ad hoc queries, aggregation, and geospatial queries. Additionally, it offers flexible indexing options to optimize query performance and improve data access efficiency. Okay, now I will show relational and non-relational examples via SQL and NoSQL. As you can see, below is the book table. Now, if I told you that the book has more than one author, what would you do? Let's think a bit. Maybe we would add a new column, right? Let's add it. We have two will, but some columns remained null because these books have only one author. As you guessed, this wouldn't be a correct approach. Not only null, but imagine a book having two or more authors. Even in such cases, creating a new column for each author would incur a great cost and would be a wrong design. Of course, the best way would be to establish many-to-many relationships, but sometimes establishing many-to-many relationships can lead to confusion. We will have to consider multiple tables and establish relationships for each and every time we select data from these tables. We would have to perform a join operation. As I said earlier, sometimes creating too many tables can be problematic in terms of cost. Okay, now let's see how this situation is in MongoDB. It looks simple and readable, right? I think so too. So we don't need to create a new table every time. We can do this in the form of a document with the help of JSON array. If a book has 5 or 10 authors, we can easily add them here. However, it's worth mentioning that although NoSQL seems easier, choose the one that fits your project and data area. Because in some scenarios, using SQL might be more appropriate. It's advisable to choose the suitable one based on difference between SQL and NoSQL. So, get started download and installation. Search to MongoDB in a web browser and click visit MongoDB official website. So click resource menu and navigate server documentation. Click installation in left side. So since my operation system is Windows, I will install Windows. So click MongoDB Download Center and select package. I will install last version download. Actually, I don't download installer package because I already downloaded them before. So you also download MongoDB shell. I already downloaded before. Close web browser and going to installation. Click MongoDB installation. Next, accept, next, click complete and installation, next, install. So waiting for installation is completed. Okay, MongoDB is successfully downloaded. Close MongoDB Compass. Currently I don't need. Extract. Next. Gosh. Going bin and click the Mongosh console and draw anyway. Okay, please enter a MongoDB connection string. This is Mongo shell and type enter. We will show Mongosh console clears and close currently. So we also add the environment variables new, variable name Mongosh, and copy location. Will variable value and okay, close the window. So I prefer using Visual Studio Code over the default MongoDB shell. You can use the default shell if you don't want to use Visual Studio Code. Click extension and search MongoDB extension. You will see MongoDB for Visual Studio Code. Install. You can see MongoDB icon and click to connect. MongoDB connection is successfully. Alright. Checking Mongo SH in terminal. Mongo SH and enter. Wow, this is great. Mongosh is already successfully. In this video we'll cover the fundamental operations of working with databases and collections in MongoDB. First, let's talk about the use keywords. In MongoDB, use is a command used to switch to a specific database or create a new one if it doesn't exist. For example, use my database will switch to a database named my database. If it doesn't exist, MongoDB creates it when you first insert data into it. Now, let's see how to create a database. You can create a database simply by using the use command followed by desired name. For instance, use my database. Enter. Let's create a collection. Collections in MongoDB are containers for documents. They are created automatically when you insert data into them, but you can also create them explicit using the db create collection method. For example, db create collection and my collection. After creating the collection, you might want to see the list of available databases. You can do using the show dbs command. These commands display a list of all databases on the MongoDB server, along with their size in bytes. Finally, let's discuss dropping a database. To drop a database, you switch to it using use and then use the drop database command. But remember, this action is irreversible and permanently deletes the specific database. Drop db drop database. Db drop database. Okay, that wraps up this video. Now you know how to use the use keyword to create database and collections with databases and drop database in MongoDB. Today we'll cover everything you need to know about creating, reading, updating, and deleting data in MongoDB. Firstly, I want to create example database and example collection. Use my DB, enter, and DB create collection, my collection. Let's start with the create operation. MongoDB offers two main methods for inserting data, insert one and insert many. For example, DB my collection insert one and scope name Alisa, age 10. Okay, inserted is successfully. This is my inserted ID. Inserted ID is automatically creating. Also, I will show you inserting multiple documents. DB my collection, insert mini, name Bob, age 5, and name Charlie, age 25. Enter. Argument docs must be okay. I forget array character. So okay, insert is successfully. Give me two object ID. With insert one you can add a single document to your collection. For more efficiency, use insert menu to insert multiple documents at once. Now let's move on the read operation. The find method allows you to retrieve documents from a collection. Let's find out. Collection and find. Here we retrieve all documents in the collection. The find method without any query retrieves all documents. Next up, we have the update operation. MongoDB provides update 1 and update many methods to modify existing documents in your collection. db.myCollection update many. First update 1. Update 1. Name Alisa and vice parameter set age. Okay. Inserted item null because we update data, and matched count 1, modified count 1. Okay, let's find out update many. db my collection update many and update age 35, set parameter status senior. Okay, I forget array character. Enter. Okay, I want to assume set age. I accidentally used the square bracket character. Remove the character and try again. Matched count 1, modified count 1. Let's see our updating data. db my collection and find. Our collection successfully working, and there you have it. With MongoDB's powerful CRUD operations, you have everything you need to create, read, update, and delete data in your database. Let's begin query operations in MongoDB. Firstly, we will need some dummy data. I will create a new collection and then proceed to insert some data. After that, I will explain the query operations. db.create collection. My collection name will be users. Enter. Collection successfully created. And db.users insert many. Copy dummy data and paste. Enter. Let's show dummy data. db users find. Dummy data has been successfully inserted. The first query operation we will explore is eq. The eq operator stands for equals and is used to find documents where a specified file is equal to a specified value. It is commonly used in query operations to filter documents based on exact matches. For example, if you have a collection of users and you want to find all users whose age is exactly 25, you will use the eq operator like this. db.users find age eq value 25. Enter. As you can see, the data has been filtered successfully. Next query operation is ne. The ne operator stands for not equal and is used to find documents where a specified file is not equal to a specified value. It is the opposite of the eq operator. For example, if you have a collection of users and you want to find all users whose name is not equal to David, you would use ne operator like this. db.users find and field, my field is name, parameter, so ne David. As you can see, all data arrived except for those whose name is John. Next query operations is GT. The GT operator is a compression operator used to query documents where the value of a field is greater than a specified value. It stands for greater than. For example, if you have a collection of users and you want to find users whose age is greater than 25, you will use the GT operator like this. db.users.find age parameter and GT 25. So 25. As you can see, this query will return all documents where the age field is greater than 25. Next query operations is AND. The AND operator is a logical operator used to combine multiple conditions in a query. It allows you to specify multiple expressions, all of which must be true for a document to be included in the query results. For example, let's say you have a collection of users and you want to find users who are both active and who have an age greater than 25. You would use the AND operator like this. db.users find AND operator status active status age 25. Let's try. As you can see, this query will return all documents where the status field is active and the age field is greater than 25. Both conditions must be true for a document to be included in the query results. Next query operation is OR. The OR operator is a logical operator used to combine multiple conditions in a query. It allows you to specify multiple expressions where at least one of the expressions must be true for a document to be included in the query results. For example, let's say you have a collection of users and you want to find users who are either active or have an age greater than 30. You would use the OR operator like this: db.users.find and OR parameter or operation status active age 30. As you can see, this query will return all documents where either the status field is active or the age field is greater than 30. Next query operations is NOR. The NOR operator is a logical operator used to combine multiple conditions in a query. It performs a logical NOR operation on an array of query expressions, meaning that documents will only be included in the query results if none of the specific conditions are true. For example, let's say you have a collection of users and you want to find users who are neither active nor have an age greater than 30. You will use the NOR operator like this: db.users and find NOR operator, NOR and status something wrong. Okay, status is active and age GT. I am also using GT operations 30. As you can see, this query will return documents where neither the status field is active nor the age field is greater than 30. The next query operation is NOT. The NOT operator is a logical operator used to negate the effect of another operator or expression within a query. It allows you to perform logical negation on a single expression or a combination of expressions. For example, let's say you have a collection of users and you want to find users whose age is not equal to 25. You will use the NOT operator like this: db.users find and so age not equals 25. As you can see, this query will return all documents where the age field is not equal to 25. You can use the NOT operator with various other operators and expressions to achieve different negation effects in your queries. Let's begin aggregation pipelines in MongoDB. Firstly, we will explain group. The group operator is used as a part of the aggregation framework to group documents by a specific key and perform aggregate functions on the grouped data. It allows you to perform operations such as counting, summing, arraying, finding maximum or minimum values, etc. On the grouped data, for example, if you want to find out how many users are active and inactive, you can use the group operator like this. db.users aggregate group ID status and count someone missing semicolon. As you can see, aggregation query will return the count of users for each status. ID active count 5, inactive count 3. Next aggregation function is limit. The limit operator is used to specify the maximum number of documents to be returned in the result set of a query. It limits the number of documents returned from the database to be specified value. For example, if you have a collection of users and you want to retrieve only the first 3 users from the collection, you will use the limit operator like this: db.users.find and limit 3. Enter. This query will return only the first 3 documents from the user's collection. Next aggregation function is sort. The sort operator is used to sort the documents returned by a query based on the specified criteria. It allows you to order the results in either ascending or descending order for one or more fields. For example, if you have a collection of users and you want to retrieve the users sorted by their age in descending order, you will use the sort operator like this: db users find and sort age -1. This query will return the documents from the user's collection sorted by the age field in descending order. You can also sort by multiple fields. For example, if you want to sort the users first by their status in ascending order and then by their age in descending order, you will use db.users find sort status 1 and age -1. Enter. This query will return the documents sorted first by the status field in ascending order and then by the age field in descending order. So, finally, if you want to sort users by their age in ascending order, like this: find and sort H1. H1. This query will return the documents from the user's collection sorted by the age field in ascending order. Last aggregation function is match. The match operator is used as the first stage of the aggregation pipeline to filter documents based on specified criteria. It allows you to select only the documents that match the given conditions. For example, if you have a collection of users and you want to find all users who are active and have an age greater than 25, you will use the match operator like this: db.users aggregate match status active and age greater than 25. This aggregation pipeline will return only the documents from the user's collection where the status field is active and the age field is greater than 25. Thank you for watching the video. I hope you found it useful. If you enjoyed it, please consider subscribing to my channel for more content.